Hello, and welcome back to Introduction to Business Analytics. This is Hari Raj Gopalan, and I will be your instructor for this session. So we are deep into predictive analytics. We've finished descriptive analytics. We have finished a good part, 1/3 of predictive analytics, which is regression. And we are now getting into data mining, which still has some regression in it, but we're going to get into the deep parts of data mining. Now, before we get into data mining, it is important that all of you download and install this analytics solver for Excel. This package will be used from now onwards until the rest of the class, and also used heavily for prescriptive analytics. So the PDF file analytics solver for students installation guide has already been posted. Please open it, follow the instructions, go to this website, enter all the data they've asked, create an account, enter the data. The textbook code and course code will be given to you. It should be there as part of your course. Copy and paste the values. Don't reverse them. Be careful there. Download and install the software. Now, before you install the software, make sure Excel is closed and not running. And then you run the solver setup program, which is the installation program. The solver setup program will prompt you to choose between analytics solver platform, risk solver platform, and Excel miner. Choose the analytics solver platform because it will install both the risk solver and Excel miner. You will get everything. When the solver setup finishes, start Excel, and you should see the ribbon for analytics solver platform and risk solver and Excel miner. I'll show Excel and show you how it looks. Click the solver per platform tab. You should see a welcome dialog and various links. Now, if you have problems with any part of the installation, please email support@solver.com. This creates a support ticket in Frontline's help desk, or start a live chat from any page on solver.com or from Excel help support live chat. So install, get it running, get it working, make sure it runs. So let's start with data mining. So data mining is an analytic technique that helps analyze, understand, and extract value from data. And a lot of times we use large data sets, but large data sets also increase processing time. So a lot of times we take a statistically representative sample to reduce process time and get us quick results. Now remember, when you talk about large data, sometimes you're looking at millions of data. So what we want is ability to extract that data. So the process of data mining is very similar. You identify an opportunity, you collect data, you explore, understand, and prepare the data, identify tasks and tools, partition the data, evaluate and build models, and finally deploy the models. Now, we are going to focus in this part on evaluating and building models. Exploring and understanding and preparing data, this comes under the data visualization part, which you've already completed. I will go through it very quickly here. So the process, first we get data. You can go to Excel data mining and get data worksheet, and I'll give you an example in Excel very soon. This is basically sampling the data. There is a tool to actually sample. You can explore the data using visualization tools like graphs, and again I'll go through some of them. You can transform the data. What do you do when you have missing data? How do you transform continuous data into categorical data? How do you transform categorical data into continuous data? Do we really need to do principal component analysis? Essentially, if you have too many independent variables, you know that just by data mining, you'll essentially get some kind of significance. So how do we group these variables together into multiple components? Maybe 2-3 variables actually give us the same thing, and so we can actually group them together, and that's called principal component analysis. And then finally, we get into analyzing the data. So the Excel spreadsheet, this is the data mining tool, and you'll see all these options. The first two steps is fetching the data, where you can fetch it from a worksheet, from a database, from a file, or from a big data like Apache Spark, which actually goes and you go fetch from a data warehouse and you bring it in. So you have options here. There is data exploration, we'll talk about that. And then there is transformation, handling missing data, transforming continuous and principal component analysis. The cluster analysis actually should be part of or next to the association and segmentation here. And there is some text analysis, which we'll go through the end. But really, we're going to look at getting data, exploring, and transforming data. So let's go to Excel before we get into further details. Okay, this is a very quick overview of data exploration, that is fetching data, data exploration, and transformation. We will get into an example problem a little bit later in a separate video. So getting data, you can do it from your worksheet, from your database, from your file. I mean, if it's a text file or a big data warehouse like Apache Spark. In this particular case, Apache Spark. Exploration has chart wizards with different kinds of charts. You can export it to Tableau and do some data exploration there. Feature selection allows you to look for which features have the highest impact and or has the highest statistical significance. Remember when we did our regression, we talked about how you should be careful about data mining and figuring out which variables have the maximum impact on your data. Transformation, how do you handle missing data? You have a bunch of options, including no treatment. You have deleting option to delete data. If you click the help, it gives you you can delete the record, you can replace it with the mode, especially if you have a categorical variable, you can replace it with a mean or median, especially if you have outliers or a user specified value. We'll go over this in greater detail in another slide. Similarly, you can transform continuous data into bins, or you can rescale it, normalize the one or more features in your data. You can transform categorical data by creating dummies, several new numerical binary variables. You can create string variable into numeric categorical variables. You can reduce the categories, total number of categories, by creating a new categorical variable. And then finally, principal component analysis, especially if you have highly correlated independent variables, you can put them into different components and take a look at this. That's what principal component analysis does. So this is a quick overview of data exploration and transformation. We'll get into more detail in the next presentation. Okay, so for data mining after exploration and transformation, we shall be looking at classification, which is using information in data to estimate what the discrete group or class and entity and observation belongs to. So group, class, entity, or observation belong to. For example, will a loan applicant repay or default? And remember, we talked about logistic regression, binary logistic regression. That falls under this. Then there is prediction. You've already done regression, which is a prediction. What is the fair market value of a given house? And you're going to do a lot more prediction. Then we're going to look at association and segmentation. Remember, we talked about unsupervised. Oh, no, we have not talked about unsupervised. I'll talk about it. But it basically allows you to form logical groupings of observation in our data. For example, what types of items are typically purchased together? Clustering falls under this. So supervised learning in my algorithms are basically classification and prediction. What we normally do is we use a data set to create the model, which is called training data. And this training data has the answers. So we have all these different variables, and then we have the dependent value of the dependent variable, and we feed the algorithm, which builds this model. Regression, if you notice in regression, that's what you essentially did. Now the training data has the desired outcome, and then we classify or predict with a new set of data, which is our testing data. Unsupervised learning algorithms, where association, segmentation, and clustering fall into this, the data sets don't have predefined outcomes or target values. So you don't know the answer, and the algorithm has to figure out what these groups are, and we'll talk about them. So finally, when we look at data mining, I want to reiterate that sampling becomes really important. Sampling must be random, must be representative, must be able to ignore the noise and errors. And if you place too much attention to the noise or errors, it's called overfitting. And what will happen is the model becomes very accurate for the sample, but not really good for the rest of the population. So the steps you take are you partition the data set, you create a training sample to create the model, you have a validation sample, use it for assessment, and then you collect new data as a testing sample, and you look at how well the model works with the data. So with this, we stop this particular lecture, and then we get into data exploration and transformation.